Okay, so today the topic we're going over, I don't think should be too bad. It's called the equilibrant, and basically it's this: if we've got any number of forces that are acting on an object that are unbalanced, there's one single force that we can apply that will cancel out all of the other forces, no matter how many there are. If there's one force, we can cancel it out with one. If there's 100 forces, we can cancel it out with one single force, and that one single force that cancels out the other forces is called the equilibrant because it establishes equilibrium. Okay, so and trust me, it's not. If you already got what we've been doing with drawing vectors, this would be no big deal. So so if we've got an unbalanced force of 10 newtons to the left, the equilibrant, the one that's going to cancel out that force, is just going to be 10 newtons to the right. So the blue arrow is our equilibrant because it balances out with the other force in this case. If we've got 15 newtons up, okay, the equilibrant is going to be 15 newtons down. Okay, and I've been drawing the equilibrant in blue. And if the force is 30 degrees north of east, 20 newtons, the equilibrant is going to be directly opposite that at 30 degrees south of west. And so now that's if there's just one single force acting on it. You just have a force that's equal and opposite. If there's more than one force acting on an object, it's no big deal. What you have to do is go back and find and add these two forces together, okay, and then find the resultant. So we've got our forces. So we've got our 10 newtons and 10 newtons. We're going to finish off our parallelogram, or a box in this case. We're going to draw the resultant, okay. And this is the thing. The equilibrant is just an arrow that's equal and opposite the resultant of the vector. So the key thing is to draw the resultant just like before, and then the equilibrant is just a line that's equal in length and opposite in direction. So if this is the resultant, then that's the equilibrant would be drawn like so. I don't know why it's not attached. So again, don't make this hard. If you figured out how to draw the equilibrant, the resultant, then it's just the same. It's almost exactly the same. So finish off drawing your parallelogram. So draw the resultant, okay, and then just use your ruler and measure how long your resultant is, and extend the line in the opposite direction. So this blue line is your resultant. Whew, I ate some jalapeno peppers. My mouth is burning. Whew. Random side note from Mr. Benabo. But anyway, yeah, that's the deal. Draw your resultant, and then draw the equilibrant as a line that's equal in length and opposite in direction. Just use your ruler and extend the line, double the length of the line, and draw an arrowhead opposite. So don't make this hard. A lot of kids make this hard when it really doesn't have to be. Here's another example where it's the vectors are not at right angles. So finish off your parallelogram. We haven't done much with these, and I'm not going to make a big deal about these, so just try your best on these, the best you can. So draw your parallelogram, then draw your resultant from start to finish. And the equilibrant is just take your ruler and extend the line and make it the same length as your resultant. Okay, skipping that one. Just kind of a side note, if all of these forces balance, let's say all three of these forces balance, cancel out, so the sum of my forces equals 0, then any one of these is the equilibrant for the other two. For example, A and B add up to be exactly opposite C. So if I add, and if you don't get this is not that big of a deal. This is just kind of an interesting side note. So if I add A and B and I find the resultant of A and B, it directly cancels out with C. Okay, and if I add B and C, okay, I come up with one that's exactly opposite A. And if I add A and C, I end up with one that's exactly opposite B, because they all have to cancel out each other. So do the equilibrant worksheet. There's one where the number 4 is one where it's the vectors are kind of at diagonals. Just see what you can do on that. Don't stress out about it too much. Good luck.